So today we're going to be learning about exponents using concrete manipulatives that we have called exponent tiles. So I'm going to talk about the tiles a little bit before we start doing some problems. So each one of these circles is an exponent tile, and you'll see that one side is red and one side is green. The red side denotes a positive or a negative exponent, and the green side denotes a positive exponent. And the power is represented by the number of tiles, and each tile has the same value of the base. So today, all of our examples are going to be with the base 3. So each one of these tiles represents 3, and then the number of tiles represents the power. So this would be 3 squared, and this would be 3 to the negative 2 power. So we're first going to just practice using our tiles a little bit. So to write 3 cubed, we can put 3 green tiles, because that's 3 positive 3's. And then for 3 to the negative 3 power, we can put 3 negative tiles, 3 red tiles. This can also be written as 1 over 3 green tiles, because we know that when we move a negative exponent to the denominator of a fraction, then we get 1 on top, and it's the reciprocal of that fraction. So it's a little practice using our exponent tiles. So here we have some examples. So the first one we're going to do is 3 cubed times 3 squared. So we know 3 cubed can be represented by 3 green tiles, and then we know that 3 squared can also be represented by 2 green tiles. Now all we have to do to find our final answer is to count all of these tiles together. So we have 1, 2, 3, 4, 5. So that gives us that our answer has the base of 3, but 5 is the exponent because we're left with 5 tiles. Alright, so here we have 3 to the 4th power times 3 to the negative 2 power. So we can write 3 to the 4th power using 4 of our green tiles, and then we can write 3 to the negative 2 power using 2 of our red tiles. So when we have 2 different colors, you're going to want to cancel the pairs of the red and green tiles. So we can get rid of 1 pair, and we can get rid of 2 pair. So that leaves us with 2 3's, and then this becomes a 1 because there's nothing left. So now we can count the number remaining. So we have 2 green tiles remaining, so that means that our answer is going to be 3 squared. Alright, so our next example is a division problem. So on our numerator, we can write 3 to the 4th power using 4 of our green exponent tiles. And we can write 3 squared in the denominator using 2 green tiles. Now, since we're using division and all of our tiles are the same color, you're going to want to cancel, just like you would in any fraction, you're going to want to cancel things that are alike. So we can cancel one set of green tiles, and we can cancel a second set of green tiles, which leaves us with 2 green tiles on the top and a 1 on the bottom. So this gives us the answer of 3 squared. You'll notice this is the same answer as the last problem, because dividing 3 to the 4th power by 3 to the 2nd power is the same as multiplying 3 to the 4th power times 3 to the negative 2 power. So in our last example today, we have 3 cubed divided by 3 to the negative 2 power. So we can rewrite this by writing 3 cubed times 3 squared. And this makes it a little bit easier to manipulate. You don't have to write it this way. You can do it as a fraction if you want. This is just a little easier. So we can write our first part as 3 green tiles, and our second part as 2 green tiles. So we know with multiplication, we count the tiles that are remaining, so that gives us 5 tiles, and our answer is 3 to the 5th. So using exponent tiles today can help us easily understand how to manipulate multiplication and division of exponents by canceling out our pairs and giving us what we need. Just cancel them out like that. So let's do the practice problems that you have in front of you.